Hello everyone. In this video, we will discuss ionic bond, which is otherwise called electrovalent bond. We have already discussed the limitations of octet rule. Even in the beginning of this chapter, we have discussed ionic bond or electrovalent bond. Ionic or electrovalent bond is formed by transferring electron from one atom to another. When electron is transferred from one atom, that atom becomes a cation. When the other atom accepts this electron, it becomes an anion. The force of attraction between these ions is what we call electrovalent bond. As per octet rule, atoms lose or gain electron to attain octet structure in their valence shell. And the rule says that the atoms and the molecule thereafter attain stability. In this video, we are going to discuss the factors which decide the formation of ionic bond. That is, we are going to discuss whether it is the octet rule that decides the stability of ionic compounds. But before we go into the details, I am Anandavalli. I welcome you all to this new video from Guidance Education channel. Please watch the video completely without skipping so that you get all points cleared, and if you think the video is useful, do like the video, share the video with your friends, and also leave your feedbacks as comments in the comment box below. If you have not yet subscribed my channel, to subscribe it now and support me. Press the bell button and all button for notification of more videos like this. Thank you very much. Come, let us start the class. It has been observed that there are two factors which decide the formation of ionic bond. One is the ease with which ions are formed with reference to formation of atoms. That is, whether it is easy to form the atom or the ion. That is what we mean by ease of formation of ions. The other factor is the lattice of crystalline ionic compounds. Let us take up the first factor. Metals have a tendency to lose electrons. Let us represent the metal as M. We have not given the name of the metal. We are using simply the letter M in order to represent the metal. The metal loses electron and becomes an ion. Let us suppose it is losing one electron. Then the metal becomes positively charged and one electron is released. What is the requisite for the metal in order to lose this electron? It has to absorb energy from an external source. The number of electrons and number of protons in an atom is the same in its elemental form. There is force of attraction between the positively charged protons and the negatively charged electrons. So, for this electron to get detached from the metal, detached from the attraction of the protons, some energy has to be supplied. That energy is absorbed by the metal. So, the metal gains some energy. Its energy changes. Energy change is represented by the term enthalpy. Here, this energy change is endothermic in nature. That is, it is absorbing energy. So, that is represented as delta ionization enthalpy. H for enthalpy, I for ionization. Ionization enthalpy. So, ionization enthalpy decides the conversion of atoms to cations. Now, come to non-metals. Let us represent them as Nm, non-metal. They gain electron and get converted to its ion. If it is gaining one electron, it gains one negative charge. This also is accompanied by energy change. But what is the nature of the energy change? This atomic non-metal releases some energy when it gets converted to ion, that is anion. So that energy is represented as delta electron gain enthalpy. Electron gain represented as Eg. This electron gain enthalpy is otherwise called electron affinity. Affinity means attachment, that is liking. Non-metals like to have more electrons. They have a tendency to take electrons into themselves. So that is what we mean by the term electron affinity. And since energy is released, it is a negative quantity. So this delta electron gain enthalpy, change in energy, is a negative quantity, whereas ionization enthalpy is a positive value. So from this we can understand those metals which easily ionize, that is become cations, and those elements which easily become anions will participate in formation of electrovalent bond. Lower the ionization enthalpy, the easier for the metal to become cation. Low ionization enthalpy favors electrovalent bond. Similarly, higher negative values of electron gain enthalpy favors formation of ionic bonds. So these are the two factors which decide the ease of formation of ions. Now the second factor that decides formation of ionic bond, that is lattice of crystalline ionic compounds. I hope you have understood ease of formation of ions. Now let us see what we mean by lattice. The three-dimensional arrangement of the particles in the crystalline solid of an ionic compound is what we mean lattice. Let us take the example of sodium chloride. I will just diagrammatically represent the lattice arrangement in sodium chloride. Chlorine remains as chloride ion. They are anions. Anions are larger than cations, and sodium remains as cation. So, the chloride ion remains as larger particles and sodium ions remain as smaller particles in between the chloride ions. These are the chloride ions. This is the sodium ion. So they are arranged in three-dimensional pattern. I have not shown the three-dimensional thing. I have shown this in two dimension. So there should be these particles shown here also. I have not shown that. Okay. So this arrangement is what we call lattice. This is possible in crystalline ionic compounds. After formation of the ions and formation of the ionic bond, these ions arrange themselves into this lattice. And when this lattice is formed, some amount of energy is released. That is, the energy of the crystalline solid will be reduced. The energy that is released during formation of crystalline lattice is called enthalpy of lattice. Enthalpy of lattice also is negative because this is the energy that is released during lattice formation. Scientists tell us that it is this lattice enthalpy, that is energy released during formation of lattice, that makes ionic compounds stable. I will explain Let us take one example. Ionization enthalpy for formation of sodium ion from sodium atom has been found to be 495.8 kilojoules per mole. That is for formation of 1 mole of sodium ion in the gaseous state. That's very important. Needs 495.8 kilojoules of energy. Similarly, formation of chloride ion in the gaseous state is accompanied by the release of electron gain enthalpy equal to 348.7 kilojoules per mole. When the molecule of the compound is formed, that molecule will have the total of this ionization enthalpy and electron gain enthalpy. What will be its total? That will be equal to, this value is positive and this value is negative. So, it will be a positive value. Positive 147.1 kilojoules per mole. So actually formation of the molecule is an endothermic process. It has absorbed energy, then how can it be stable? Because we have the concept that lower the energy, greater the stability. Remember, while formation of the ions, octet structure is obtained. But in spite of that, energy has increased. Then how is it that the crystal is stable or the molecule itself is stable? It is found that for sodium chloride, the lattice enthalpy is found to be negative 788 kilojoules per mole. Huge amount of energy is released during lattice formation. This compensates for the increase in the energy when the molecule is formed. From this, we can easily understand that the stability of the ionic compound sodium chloride is not due to the octet structure of the valence shell. It is mainly due to lattice enthalpy. Ionic compounds exist as crystalline compounds. So there is lattice there. So as soon as the compound is formed, the lattice is formed. And when the lattice is formed, lot of energy is released. It is this lattice enthalpy of crystalline ionic compound that decides its stability and not the octet structure attained by the corresponding ions. I hope I have made it quite clear. Now let us see the definition for lattice enthalpy. Lattice enthalpy of an ionic solid is defined as the energy required to completely separate 1 mole of a solid ionic compound into gaseous constituent ions. Here, the lattice enthalpy that is given is the energy released when 1 mole of the crystalline ionic compound is formed from the concerned ions. But by definition, lattice enthalpy is defined as the energy that has to be supplied in order to break a lattice of 1 mole of ionic compound into the constituent ions in the gaseous state. So in terms of definition, lattice enthalpy becomes positive because it is the energy that is absorbed. But in reality, it is a negative quantity because it is actually the energy that is given out. Then why is the definition given like this? This is because formation of the lattice involves attractive forces as well as repulsive forces like ions. That is, positive ions repel among themselves. Negative ions also repel among themselves. But the positive and negative ions also attract each other. So it becomes very difficult to calculate lattice enthalpy directly. So we depend on indirect method. That's all. Moreover, The energy given out during formation of lattice will be the same as the energy that has to be supplied when the lattice is broken. Hope this topic is quite clear for you. We will meet in the next video with another important topic like this. Till then, bye. Take care.